Greetings from VLSI. I'm Panu, writer of the VSOS kernel, and today I'm going to explain you some basic concepts of VSOS operation. Okay, let's take another look at how we can use VSIDE to program a VS1005 Developer Board with the VSOS kernel and what we can do to make it do stuff. I have here a makeshift document camera filming the display of a developer board which is unprogrammed. So once again, to program it we need to build a kernel. In VSIDE, new project solution, 1005 solution, and let's give it a name, VSOS 307. Next, and select kernel for internal or external flash. Build the kernel, and by default it uses the external flash. If you want to use the internal flash or need to change the flash parameters, here in this file there are some options. Uncomment this line. Now it would use internal flash, but we want to use external flash. Okay, and then program it. Program flasher utility, external SPI flasher program, next, start. And for the first time when you run it, it doesn't know what the serial port is, so it fails. We need to auto detect. Okay, it doesn't auto detect, so let me reset the board once again. I click the boot select and reset and try to auto detect again. Now it auto detects. Great. And now we can start the promer. And it's programming. Let's see the board. And when we reset it, the LCD backlight comes up, but there is nothing on the screen. To see what's going on, let's click close here and open a serial port terminal and reset it again, and we can see the output of the VSOS, and we can see here the display. And there is nothing on the display because there's no device drivers in the SPI flash. The SPI flash now just contains the kernel, but there is nothing in it. Now to put something in it, we need to connect the 1005 to the PC with the USB. So here I have a USB AV cable connected to the PC, and I will now click S1 and reset. And you can see that the kernel starts and the USB comes up. Windows detects the flash and says that you need to format it. So let's format with default parameters. Start, and format complete. Let's see. Here it is, removable disk F, 1.84 megabytes. If you would use the internal flash, then this one would be 0.8 megabytes. And at the moment it's empty. I will try to arrange these windows so that it's easy to demonstrate. Okay. Now, first of all device drivers in the VSOS, they go to the folder sys. So let's make a new folder, sys. Okay. And there is a configuration file which says what device drivers to load, and that is called CONFIG.TXT. So I make a new text document, CONFIG.TXT. Okay. And there is now nothing on the sys folder, so we need to get some device drivers there. Even now, if I reset this now, you would see something different. You would see that there is no error anymore when you boot it up. So let's just try that. Let's safely remove this one. Inject. Okay, save to remove. And now I reset, press reset once again. Still nothing happens, but instead of having an error device not open after detecting the SPI flash, we now have SPI flash handled by FAT. So it can read the SPI flash and detect what's inside. Okay, let's continue. Probably the first thing that you would like to do is to get something happening here on the LCD screen. And in the VSIDE, there is a template for an LCD device driver. Let's make a new solution and let's call this LCD or LCD driver or LCD, well, let's just call it LCD, okay? And this one would be a VSOS 3 template, and here is the LCD display driver template for the developer board. Okay, yeah, sure. And let's build this. Okay, it is built, and the build compiles this, and the linker, for historic reasons, creates a file called loadable.app. And so this is the output of the linker and actually the executable program. Now we need to copy that to the flash and rename it. Now there's a new feature in the VSIDE called target drive, and using this we can select the disk. Okay, we need to reset the developer board once more with the S1 button pressed down and reset. Oh, sorry, reset. I'm having trouble hitting the correct key. Okay, with the S1 button reset, we can see the flash contents once again here. Yes, so we need to get the device driver here into the sys folder of the flash, and we can do this in VSIDE. Now we have the removable disk F. Select this as the drive which contains the VSOS target drive. Okay, and now when we build, let's rebuild it. It automatically does a copy command, copy loadable.app to fsys, and rename it to lcd.dl3. And the LCD is here, the name of the solution. And the extension is DL3, meaning Dynamic Library 3 for, it's a DLL for VSOS 3. And we here see that in the sys folder of the flash, now there is the LCD screen. Let's see the board once again and safely remove, and reset. I forgot to make the control file. Okay, S1 reset once again to see the contents of the flash. Okay, so of course it's not enough to have the device driver here in the sys folder. I need to write to the config.txt the name of the device driver for VSOS to load. So let's write here LCD to make the VSOS load the LCD device driver. So I could also make a comment here. I can write a comment here, load the device driver sys lcd.dl3, which would be the VSOS name for the LCD driver. Okay, save, great, and reset, and let's see if it's different this time. Right, first safely remove and reset, and now we see that the display comes up. The LCD screen is initialized. Okay, here we see that it tries to load LCD and says one driver loaded. So now the device driver for the LCD is loaded, but there is nothing right now writing or using the LCD. Now let's take a look at how the LCD device is working on the VSOS. The LCD device driver has this function called Init, and under VSOS actually we should use main. Under VSOS 3 or 7 and later now this should be called main. I will explain the functionality of init and main. Well, actually, I could now tell you. There are 3 entry points in the device driver that are used by the VSOS. There is void init, void init, void this is run when the driver is loaded, and then after the driver is loaded, the main is called, and it can get some parameters also. Internally, VSOS gives parameters as a string, and later on we are going to add a feature into the linker to be able to use a standard C type parameter passing. But for now we used carp parameters, and then there is a third entry point, void fini, and this is called when the driver is dropped from memory. So in a VSOS 3 device driver, you should put memory allocation in init and memory release in fini, and the startup code of the device driver in function main. Let's build this once again. Okay. And the LCD init function here firstly it initializes the LCD, sets up some parameters in the LCD0 structure, which is the default display of the VSOS. And then it sets two handlers, LcdFilledRectangle and LcdTextOutXY. Now the only thing that VSOS needs to write to use an LCD display or any display is a function called LcdFilledRectangle. And we can find the definition for the LcdFilledRectangle in lcd.h. So it's a function that takes these parameters x1, y1, x2, y2, and either a texture or a single color. And the only thing that you need to use an LCD display in VSOS is a library which has this function hooked into the handler LcdFilledRectangle. The other entry point in the LCD driver is this LcdTextOutXY, and this is a function through which the OS can write text to a display. Actually, the implementation of LcdTextOutXY, my LcdTextOutXY here, is independent of the LCD screen. This one, if you make a new device driver, you can just copy this to your device driver, because this one just uses the LcdFilledRectangle function and the LCD0 struct to use the LCD. So this is independent of the LCD screen. Now you might ask, if it's independent of the LCD screen, then why is it here in the LCD display driver? Now the reason for that is that some displays have more efficient ways of typing characters to the screen than using filled rectangle. They might have internal font generators or something like that. Or the display might not be a graphical display altogether. You could have a text display, something like 80 by 25 text, and you could create this LcdTextOutXY function to be able to have some sort of positioned display text on that device, even though it's not graphical. But for a graphical LCD, provide the LcdFilledRectangle and then either use this LcdTextOutXY or make something that is more optimized to the LCD screen that you are writing the display for. Okay, and so what the driver does is it just gives these handlers, these services, so that the OS can use. And you can see on the display that it's working. It writes this text to the screen. We could actually add something here. We could say LcdTextOutXY 1, let's say 40, 40, and these parameters that are passed here. Okay, and let's build this again. Once again, reset the board to see the flash, build, rebuild, and now it's being copied to the flash. And if we edit the CONFIG.TXT and give this some parameters, hello all, and save this and safely remove and see the camera and reset once again, we can see that the new driver calls this LcdTextOut 40 parameters, and here to the position 4040 is the hello all that we wrote to the config.txt. So you can also see the parameter passing, how it's done in actuality. Okay, but we probably want to do something more complex. We want to have the OS do some interaction with the screen. So maybe I take this one away, reset once again with the S1 so we can see the flash here again, and rebuild it to get rid of the hello all text there. And we now make a new driver. We make the LCD console driver. It's a VSOS application. Once again, let's call it LCD-con, short for LCD console, and here is LCD console driver. Okay, and this one is a little bit different. This, well, the LCD display device driver installed some function handlers. Now this one rewrites the stdout file. So this one overrides or redirects the standard output of VSOS to this driver. And the way it does this, it creates a new file. Its type is simple file, LCD console file, and it just has some flags and console file operations. And the console file operations are, this is the most important. In VSOS.h, the stdout just needs this function write, and the LCD console driver provides this function console write here in console.c, and this is a method for outputting a stream of characters to the screen. Okay, let's build this one, build solution, and now it's copying this to the flash sys lcdcon.dl3. Let's see, in sys there are now two drivers, LCD and LCD-con. And now I remember to write here LCD-con, LCD console. Okay, let's save this, save, and now it, oh, yeah, sorry, my mistake. See the board once again, see the terminal. Let's clear this for clarity and safely remove and reset. Here we can see that first of all there's now two drivers are loaded, and some of the output is now directed to the LCD screen, and some of the output is coming to the UART, the serial port. And what happens is that there are two output files, standard output and standard error, or stdout and stderr in VSOS. And the LCD console driver redirects the standard out, but the standard error goes to the serial port still. If we take a look at the kernel, recent solutions here, and the stuff that happens when the kernel begins, we can see here that after the load drivers there is some output to stdr, and then there is some output with just printf. So we can see that this sinit app not found, nothing to do, this one goes to the LCD, but writes to the stdr load sinit.ap3 here, go to the UART. So this is very useful for you also. You can use the messages that you want to show to the user, you write with printf, they will go to the LCD screen, and the debugging information that you need for yourself, you write that to stdr like this, fprintf vo stdr, and whatever you like. You can also write to stdr, and if the std input output header file, which is loaded and for the C file, is VOSTDIO, then stdr will go to, where is it? Then stdr will go to VOSTDR. And if you are running the same program on a PC, because it's a fairly standard C type program, you can run these on a PC, actually on any POSIX style operating system, and you can run them on VSOS. Then stdr would go to the PC when you are running this on PC, and to the VSOS output when you are running this on VSOS. But sometimes, because we have in the emulator, in the VSMU emulator, we have the possibility to have input and output also, we might like to do more, both VSOS stdr std out and non-VSOS std out stdr. So in those cases it would be necessary to prefix the stdr with VO. I just do it for safety. Even if the headers are wrong, or I have included different header, I can be sure that this one goes to VSOS stdr. So I write VO stdr, but I could also just write stdr. Right, so anything after loading the LCD console driver goes, any std out after loading the console driver goes to the LCD. Now the next thing probably would be this init.ap3. It says init.ap3 not found, nothing to do. So let's now put an application into the system, and we should have here a solution template for main menu. So let's call this init and use the main menu application. Okay. And this one is the main menu that you see. It's the same that you have seen in VSOS 2 already before. And let's just reset this once again with the board once again with the S1 pressed, so we can see the flash contents and build it. And now even this one, it makes an fsys init.dl3. So let's copy these, cut, paste, and rename it to init.ap3. And this one is, as you can see, the libraries, device drivers are libraries, and the applications, the file format is the same. There is no difference on the file format between libraries and device drivers and applications. The only thing that is different is what they do, how they are called, and what kind of functions they provide. So let's try to run it. Now we have this init.ap3. And let's try to run it. Once again, we safely remove and reset. And we can see something of the main menu. Let's see the terminal here also. We see the main menu is sort of running, but it looks a little bit weird. We should have some buttons here, something like that. The main menu uses standard buttons or STD buttons. Here it creates standard button info, configure touch, and some text information. And the kernel has a very basic implementation of standard buttons, which enables the kernel just to show the standard buttons as a list on stdout. This may be very useful in some circumstances. But we require now the standard buttons to be presented on the LCD screen. So let's see how to do that. There are no templates in VSIDE for those drivers, so let's go to the VSDSP forum. VSDSP forum, VSOS software, kernel release thread, scroll down, bottom of the first page. There's a collection of some drivers, and here in SYS we have these two drivers, the touch button, no, the touch screen driver, and the standard button driver, which uses the touch. Reset the board once again so we can see the flash, and to the SYS copy these two drivers, and then in the config.txt load these two drivers. First the touch 288, and then stdbtch. Right. So once those drivers are loaded, save, then let's see the board and terminal and safely remove and reset. And now we see did I miswrite the touched 288? Let's see. Reset with S1 to see. Touch 288. Save and safely remove and reset. This open failed is because it tries to read the calibration information of the LCD, but it seems to be working. Info, yep, the touchscreen is definitely working. Now we just need to calibrate, touch all these 4 corners, and now it seems to be fairly accurate. And click OK, and now the LCD screen is calibrated. If we take a look, reset once again with the S1 so we can see the file, it has written a VSOS.ini file here. If we open this with the WordPad, we can see that it has written some calibration parameters of the touchscreen here. And if we reset it once again, we now see that all the drivers are loading and there's no errors or anything. So now we are good to go and the board is doing something. It's great. We'll continue from here the next time. Thanks again, I'm Panu from VLSI. Bye bye.